In this question, the electric potential existing in space is given by V x comma y comma z, that is the potential in xyz is given by A into xy plus yz plus zx. Now in first part we had to calculate a dimensional formula for A. Now for that we should know the dimensional formula for potential V, and the dimensional formula for potential is m L to the power 2 t to the power minus 3 into I to the power minus 1, where m is mass, L is length, t is time, and I is current. And on right hand side we had terms like xy, yz, zx. So dimensional formula for this kind of terms will be L square, because x is length, y is length, so the dimensional formula will be L square. Now equating the dimensions of left hand side as well as right hand side, we have m L square t to the power minus 3 I to the power minus 1 is equals to dimensional formula for A that we have to calculate into L square. So the dimensional formula for A comes out to be m t to the power minus 3 I to the power minus 1. This is my answer for first part. Now in second part we have to calculate the expression for electric field. Now we know that small change in electric potential is given by minus E dot product with length vector. So dV here is calculated by a formula which is pretty out of course, but the formula is del V by del X into dx plus del V by del Y into dy plus del V by del Z into dz. Now we have the expression for V, and del V by del X is A y plus Z, del V by del Y is A x plus Z, and del V by del Z is A x plus Y. Now substituting this 3 into this equation, we get dV as A y plus Z into dx plus A x plus Z into dy plus A x plus Y into dz. Now we know that dV is minus of E dot dl. Here dl is dx I cap into dy j cap plus dz k cap, and the electric field can be written as Ex I cap plus Ey j cap plus Ez k cap. So E dot dl, the minus sign, can be written as minus of Ex dx plus Ey dy plus Ez dz. Now since dV is equals to minus E dot dl, comparing the coefficient of dx on both the side, we have Ex equals to minus of A y plus Z, Ey is equals to minus of A x plus Z, and Ez is minus of A x plus Y. So the net electric field can be written as minus A y plus Z I cap plus A x plus Z j cap plus A x plus y k cap. This is my answer. Now in third part, we have to calculate the magnitude of the electric field at a point given as x is equal to 1 meter, y is given to as 1 meter, and z is given as 1 meter. So we have the value of electric field. Now substituting x equals to 1, y equal to 1, z equal to 1, and a equal to 10 SI units in this equation, we get minus of 10 into 2 I cap plus 10 into 2 j cap plus 10 into 2 k cap, which comes out to be minus 20 I cap minus 20 j cap minus 20. So the magnitude of electric field is easily calculated by 20 square plus 20 square plus 20 square, which comes out to be 34.65 Newton per Coulomb. That is our answer.